Hey guys, Mr. Wilson here. Today we're going to look at solving inequalities notes. At the end of this video, you should be able to solve inequalities and you should be able to show all solutions to inequalities. Okay, recall from last lesson that inequalities have infinitely many solutions. Okay, therefore, to show all the solutions, we have to graph the inequality. Okay, when we're solving the inequalities, we are finding the boundary between the solutions and the non-solutions. Okay. The numbers that make the inequality true and the numbers that don't make the inequality true. In other words, the numbers we find after solving is the number that separates the solution from the non-solutions. This number is sometimes a solution. Sometimes the number that separates it is a solution. Sometimes the number that separates it is not a solution. Okay, cool. All right, I'll have the lasso effect up there for this video for some reason. Okay, so here it says show all the solutions to the inequalities. So we want to solve this, and solving is not going to be a whole lot different than if we were using just equations. So to get x by itself, I'm going to subtract 6 from both sides, and I get x is, sign is here, less than 2 minus 6, negative 4. So I graph this, negative 4, less than means an open circle, go to the direction of less thans. Okay, so the left. Number 2, 8x is greater than negative 40. I'm going to divide both sides by 8. X is by itself then, so I have x is greater than or equal to negative 5. So at negative 5, greater than or equal to tells me to use a closed circle, and then I'm going to go to the right, shade to the right. Now number 3, we have negative 2x is greater than or is less than or equal to 14. To get x by itself, I'm going to divide both sides by negative 2. And here's where it's going to be a little bit different for inequalities and equations. When I divide by a negative number, I have to flip the sign. So it becomes greater than or equal to negative 7. Graphing is just the same, negative 7, closed circle, going to the right, boom. Now here you might say, well, why are you flipping the sign there? That doesn't make sense to me. Okay, let's look at two numbers. If I give you the numbers 5 and 7, and I ask you to put an inequality sign here, what inequality would you use? We can say, okay, well, 5 is less than 7, right? So now let's look at this and say, okay, well, let's multiply both sides by a negative number. Let's multiply both sides by negative 1. Okay, from there we have negative 5 and negative 7. What would our inequality be in this case? Well, I'd rather have negative $5 than negative $7. That means I owe less money, right? And so because we multiply by a negative number, our inequality flips. Okay, and so we have to make sure that we keep that consistent as we're solving for an unknown variable. Let's talk about it. Okay, so when does the sign flip? The sign flips when you multiply or divide by a negative number. Okay, when you multiply or divide both sides by a negative. It does not matter if the answer is negative. Okay, we don't care if the answer, the solution is negative. That doesn't play into whether we flip our sign. It's only if we multiply or divide both sides going into solving for a variable. That's the only time that we have to flip our sign. Okay, so let's do a few more problems here. All right. So we have 1 is greater than x minus 7. I want to get x by itself. I will add 7 to both sides. And so I have 8 is greater than x. And I always like to write some of my variables first. X is going to be a closed side to x, 8. Okay, so 8. This will be an open circle because it is not or equal to. And then I'm shading to the left. Two-step inequality here. I'm going to subtract both sides by 8. So I have negative x over 3 is greater than or equal to negative 6. And then I want to get rid of this one fell swoop. So I want to multiply both sides by negative 3. And here I've multiplied by a negative number. So I have to flip my sign. I have x is less than or equal to positive 18. As I graph it, 18 here is that boundary. It's a closed circle because it's or equal to, and it's going to the left. And then finally, number 6, subtract 3 from both sides. 12 is less than negative 2x. In this case, I'm going to divide both sides by negative 2 to get x by itself. And here again, I'm dividing by a negative. I need to make sure that I flip that sign, negative 6. I'm flipping now, x. Okay, and so this is my final answer. I'm going to write it so my variable goes first, making sure that I keep my signs orientation the same, pointing towards x. So x is less than negative 6. Negative 6, less than means open circle. Going this way. And zoom out, try to get to the next page. All right, next page here. Here it says find the solutions to these more difficult inequalities. Now with these more difficult inequalities, we're basically getting to multi-step, okay, where we would set multi-step equations, but we can do that because we had to get to this point in the year. Okay, so now we're just solving for x. Let's go through it. For number 7, we're going to multiply both sides by 6. We get 5x plus 12 is greater than 42. Subtract 12 from both sides. So 5x is greater than 30. And then divide by 5. So we end up with x is greater than 6. So all the stuff that we talked about with equations really carries over. The biggest change is that when we multiply or divide by a negative number, we have to flip the sign. Okay, so for number 8, my first thing, I'm going to make sure that I take into account the sign in front of this 2 before I distribute. Then I'm going to distribute here. I get 5 minus 2x plus 20. Negative times the negative is positive. Is greater than or equal to 13. Combine my like terms. Negative 2x plus 25 is greater than or equal to 13. Subtract 25 from both sides. So I get negative 2x is greater than or equal to negative 12. And then I divide by negative 2 to get x all the way by itself. And I get x is, since I divided by a negative, I had to flip my sign, less than or equal to positive 6. 6 less than or equal to, so it's a closed circle here. Going this way. Okay. Numero 9. Number 9. All right. Fractions, we can do those. I'm going to distribute 2/3. 18 divided by 3 is 6. X. 30 divided by 3 is 10. Plus x. Combine my like terms. 6x plus x is 7x. 7x minus 10 equals 4. Oops, I said equals. That is actually a very common mistake. Make sure that you keep your inequality an inequality. Okay, add 10 to both sides. 7x is, or 14 is less than or equal to 7x. Divide by 7, and I get 2. Okay, as I write my solution, I'm going to write it so that my variable leads open facing the x. So I'll make sure it stays that way. 2, close circle, where the greater numbers are. And then finally, distribute that -3. So I have 5x minus 6x minus 21, 80 on this side. Combine my like terms, I have -x here. I want to add 21 to both sides, 101. And then I had to divide by -1 or multiply by -1. So I get x. Oops, I don't want to do that right now. I don't want to do that in the same step. Because I have to divide by -1, I want to make sure that I get this by itself before I flip it. I don't want to take too many steps at the same time. So now I have x is positive. I have to flip my sign. And so this sign is pointing to the x as I write my answer. It's going to point to the x, -101. That's going to be my boundary, open circle, going to the left. Okay, so what we've done here, we looked at solving inequalities, added that to our already, our information that we've picked up last lesson of graphing them. Okay, and then the big takeaway that we took, or the big addition that we added today, was making sure that when we multiplied or divided by a negative number, that we flip that sign. Okay, please do not try to do too much at one time, because that's where the mistakes happen. Step by step. See ya.